Here's where you are. Week 1, Lesson 1.5, the last lesson of Module 1. By the end of this video, you'll be able to spot when Claude's answer is wrong, even when the math is right, and you'll have a 4-move toolkit you can run before anything leaves your desk. That matters because every technique we teach from here forward makes Claude more powerful, and more powerful tools need sharper judgment, not less. Let me tell you why I take this so seriously. I worked as an AI tutor at a major AI firm in the finance domain. My job was to evaluate whether the model's outputs were accurate. And day after day, I marked 2 kinds of errors. First, the arithmetic slip, a number that was close but off by a few basis points, a formula that did not match the answer it claimed to produce. The second kind was harder to catch and more dangerous. The math was right. The numbers were clean. But the answer solved the wrong version of the question. ROI meant one thing to the analyst and another thing to the client. Annual return measured partial year performance. The calculation was correct. The conclusion was misleading. That experience is the reason this lesson exists. Fluency is not accuracy, and accuracy is not always correctness for the question you actually needed answered. Now I could show you a slide listing 4 verification moves, and you would forget that slide by Monday. Instead, I'm going to run one prompt, and I'm going to show you 3 answers to it. 2 from Claude, Sonnet, and Opus, and 1 I worked out by hand using the same inputs but a different ROI convention. 2 model runs. 1 check by hand, 3 answers. And the question that matters is not which model is smarter. The question is, which answer would you sign your name to and why? Let's go. 1 prompt. A $500,000 automation project. I'm asking Claude Sonnet for 4 numbers in a tiny table. The table fits on one screen, no scrolling. Watch what comes back. Read this. 4 rows. Formula next to value. Clean, confident, board ready. And the question I want you to hold in your head is not, did Sonnet get this right? The question is, would you catch it if Sonnet got them wrong? Because this table might be perfect, or it might not be. Let me show you why you cannot tell by reading the values. 4 values are highlighted on your screen. Here is your question. Pick the one you would verify first if this table were going under your name to the CFO tomorrow morning. 10 seconds. Pick one. Watch this. I'm starting a new conversation, switching the model to Opus and running the exact same prompt. Same inputs, same wording. Only the model changes. Watch the cascade. Sonnet's wrong margin feeds into its payback row, into its ROI row. One broken cell in row un contaminates every downstream number. Move 2. Recompute the formula. If the formula Claude shows you does not produce the value Claude shows you, trust the formula. Move 3. Follow the cascade. One wrong input almost always produces more than one wrong output. Opus got the math right. 200,000, 90,000, 40.9 months. Negative 78% ROI. Arithmetic is clean. Formula matches value on every row. So we're done, right? Ship it to the CFO? No. Here's where this lesson earns its name. Because I also ran these same inputs through a different ROI convention by hand. Same margin, same ongoing cost, same payback, and the ROI comes out completely different. Look at the ROI row. Opus says negative 78%, My own by-hand check says positive 22%. Both are arithmetically correct. The difference isn't a math error. It's an assumption. Opus used full project ROI, benefits minus all costs, divided by the capex, a standard accounting convention for whole project returns. My recalculation used the period yield on invested capital, operating benefits divided by capex, without subtracting the capex itself from the numerator. A standard convention for first-year yield on capital deployed. Both are real formulas used by real CFOs. Neither is wrong in the abstract. Both are wrong if they don't match what your readers thought they were asking for. That is a force verification move. Question the assumption, not just the label. 2024 ROI means at least two different things depending on who's reading it. Before you send, your job is to make the assumption explicit and confirm it with your reader, not guess. Sit with what you just watched. One prompt, 3 answers. Sonnet got the math wrong. Opus got the math right. And a by-hand check under a different convention with arithmetic still right gave a different number still. When I was evaluating AI responses at a major AI firm in the finance domain, this is exactly the shape of error I marked every single day. Both shapes, the arithmetic slips, which you catch by recomputing, and the quieter ones, right math, wrong convention. The kind of error where the numbers hold up and the conclusion still misleads. That second kind is the one that survives review. That is the one that ships. And that is the one that ends careers. Verification is not paranoia. Arithmetic verification keeps your numbers right. Assumption verification keeps your name off a retraction. Your verification toolkit has 4 moves. 1. Check inputs. Before you look at the numbers Claude produced, check the numbers Claude read. A misread input at the top of the response breaks everything underneath. 2. Recompute the formula. If Claude shows its work, do the arithmetic Claude displays. If the formula doesn't produce the value on the screen, trust the formula. 3. Follow the cascade. One wrong input almost always produces more than one wrong output. 4. Question the assumption. Before you accept an answer whose math checks out, name the convention it assumes. Annual ROI, 2024 ROI, first year yield. These labels hide formulas. Ask your reader or ask yourself honestly which convention they meant. 4 moves, under a minute each. To catch math errors, to catch meaning errors. And this is the point. None of them require you to already know the right answer. All 4 moves point to one principle. You are the author, you own the output, and you own the assumptions that produced it. If you hand your boss a report with the wrong number, your boss blames you, not Claude. If you hand your boss a report with the right number answering the wrong question, your boss also blames you, and that one is harder to defend. Verification isn't paranoia, it's accountability. And it's what separates a professional who uses AI from someone who copies and pastes. 3 mistakes I watch beginners make. First, trusting polished formatting over correct arithmetic. A clean table is not a correct table. Second, checking the final number and skipping the inputs and formulas that produced it. The error is almost never in the line you read last. And third, the one that takes the longest to unlearn. Assuming correct math means the right answer. 2 defensible formulas produce 2 defensible numbers. Opus and a careful second run can both be arithmetically clean and still disagree. When that happens, The answer is not pick the bigger model. The answer is name the assumption, confirm the convention, then send. If you don't know which convention your reader expects, ask. Don't guess. Here is your task before you start the hands-on activity. Open a new Claude conversation. Run a quantitative prompt from your own field, a calculation, a projection, an ROI. Then do two things. 1. Run at least 2 of the 4 verification moves. 2. Name the assumption embedded in your prompt, the convention you're implicitly asking Claude to use. Then write 3 sentences. What you asked, what assumption your prompt made, and which verification move caught the problem or confirmed the answer. That 3-sentence note is your first entry in a verification log you'll keep across the rest of the course. That wraps Module 1. You now have the foundation, what Claude is, how to talk to it, the persona pattern, and the 2-layer verification habit. In Module 2, we go deeper. Few-shot prompting, chain of thought, templates, recipes, and artifacts. The prompts get more powerful, and so does your ability to shape what Claude produces and what assumptions Claude works under.